Hello, my name is Matt Fields. I am a third-year graduate student. I work with Dr. Andrew Mann at UNC Chapel Hill. And the project I've been working on as part of my NC Space Grant Fellowship is called How Often Do Planets Form Misaligned with Their Host Stars? So here I'll talk a little bit about how planetary systems form, what it means for a planetary system to be misaligned, and how we might be able to tell how often planetary systems form misaligned. So here is my simple representation of the process of planetary system formation. Starts with a dense clump of gas and dust, and the clump is rotating together, and it's getting more and more dense and more hot, and it's spinning faster and faster until eventually it collapses into a flat disk. And at the center of this disk is where the material is the hottest and the densest, and that's where the star forms. And so this process takes about 1 million years. And at the end, we're left with the star spinning at the center of this disk of gas and dust that's rotating around the spinning star. And the disk we call a protoplanetary disk. And that's because in another 10 million years or so, the first planets that will form in this system form from the protoplanetary disk. And just for reference, 1 million years, 10 million years, these are relatively small timescales, short timescales, compared to, for example, the age of the solar system is several billion years old. So these processes happen pretty quickly in the star's lifetime. Speaking of the solar system, when I think of the solar system, I think of this flat plane of planets orbiting our star, the sun, and the planets are orbiting in the same direction as the star is spinning. And this very much follows the classical representation of the process of planetary system formation, which is what I just shared. But as we've discovered thousands of planetary systems over the last 3 decades or so, we've discovered that not all planetary systems look the same way as our solar system. And on the right, I have a diagram that illustrates this, where some systems are shown to have planets that are, their orbits are sort of tilted with respect to the spin of the star. And the spin of the star being the gray arrow. And we can see that the blue arrow representing the orbit of the planets is offset from the spin of the star. And usually we assume that if any of these systems, which we call misaligned systems, if any of these systems are misaligned, these misalignments will happen after the formation of the planets. So the planetary system forms in the same way as our solar system, as represented on the left. And if it's going to be misaligned, it'll be misaligned sometime after it's formed. But the question that I'm asking in my project is, what if these planetary systems form misaligned? And so in order to answer this, we can look at the intermediate stage of planetary system formation, which is the stage with a protoplanetary disk. The idea being, if we can tell that the disk is misaligned with the star, then there's a really good chance that the planets that form from that disk will also have formed misaligned with the star. And so in order to calculate or measure whether a disk is misaligned with the star, we have to measure the inclination of the disk with respect to our line of sight, and separately measure the inclination or calculate the inclination of the star. And comparing these two will tell us whether a system with a protoplanetary disk is aligned or not. And if we repeat this process for many stars, we can get a better picture, a better statistical picture of how often planetary systems form misaligned. And so there are 3 keys that I'd like to end with that kind of summarize 3 takeaways that I'd like you to get from watching this presentation. And that's planetary systems form from stars with protoplanetary disks. Planetary systems can be misaligned, which is unlike our solar system, which is aligned. And lastly, planetary systems can form misaligned if the protoplanetary disk is misaligned. And so I hope you've come away learning something from this talk, and I'd like to thank you very much for watching.